Welcome back at the Chaos West stage, where you can hold your talks. The next talk is held by Jardi about personal servers.
Thank you.
Go ahead, Jardi.
Well, let's start. My presentation, I'm going to try to show a possible alternative to solve the big problem that we have when we want to connect final users to the decentral world. As you know, right now we have many centralized servers like DNS or the same web pages or the data centers, and big servers are very much centralized. And in the other side, we have a very good decentralized tools like, for example, IPFS, Ethereum, Namecoin. There are a lot of tools that are very good. They are decentralized servers, but we have a problem when the final user wants to connect to these decentralized alternatives. So the proposal that I am making here is that mainly is that everybody have a server. I know that this is very difficult. I do not pretend that everybody starts a server, but I strongly believe that there is people that can create a server and share this server with maybe his friends or his first circle of people. So the idea mainly is, you can see this in this schema. So you have your personal server. To your personal server, you connect via VPN, the mobile, the tablet, the desktop. You can even have like 2, 3, 4, 5 users, maybe your family, your neighbors, or your other friends that connect to the server. And in the server, in this server, we install a set of decentralized tools like, I don't know, for example, a DNS resolver or a blockchain or an IPFS node or whatever decentralized tool that we want to install. So this is mainly the main architecture that we have here. Okay, so what I'm going to explain from now on is just explain how to do, for example, to visit a pure decentralized web page. In this case, I'm going to use ENS name services, in Ethereum name services, in order to resolve a name, and connect that to an IPFS in order to get a simple static page. Okay, so the way to do that, first of all, we have to connect the client, the end client, to the personal server. This step that could look very difficult, but at the end is not much more difficult than connecting to a Wi-Fi, that most of the users know how to do it. I know that's a difficult process, but it's only once set up process, and it's not much more difficult than creating a Wi-Fi. You must think that most of the current operating systems already have all the software. They already have in place where you can configure many different kinds of a tunnel of a VPN with a specific server. So one possible solution could be to use L2TP over IPsec, but PPTP or any other IP. In this case, I'm using L2TP over IPsec. Once we have the client connected, the setup the way that we connect the VPN is a setup where we don't send all the traffic through the VPN as a normal VPN. What we do is, okay, we let all the traffic go the same way, but we push the DNS configuration to the client. This is quite very much a standard option when you configure a VPN connection. So what we do is we create in our personal server a bind or a DNS resolver software, and when the client connects to the VPN, actually the client will use our DNS, instead of using their standard DNS. In our DNS, our configuration, what we do is mainly we just forward the query to a regular DNS in general. But we catch, if, for example, somebody asks for a decentralized domain, for example, a .eth or a .bit, then what we do is we just redirect that name to our server so that we can handle it. Okay? This is how would look more or less a DNS record. The most important line here is this one. We say that everything .eth goes to this private IP, which actually is the address of our server. Okay, and this is the configuration that we have in the DNS on our server. Okay, so when somebody asks, I don't know, Bailina.eth, it will solve, and we will ask to my server to serve the page to Bailina.eth. So then we just need a simple piece. It's a kind of forwarder that just takes this query, this get, HTTP get, okay, and it just in the case of ENS just goes to the Ethereum in the same server we have an Ethereum node. So it goes to the Ethereum, it checks which is the actual in this case IPFS hash that we extract from the ENS Ethereum, and then we get this hash and go to IPFS and get this hash, and all that we go and we forward that to a customer. This that looks very quite difficult. At the end is not more than 10 lines of code. I'm going to show you the lines of code. I think it's interesting. The first, we could just create a server. The first lines we configure, we just ask the ENS to resolve to a hash. This is what's done here in this second part of code. And then we just forward that to a local host, which is 9001. That's where actually is running a gateway, a IPFS gateway. So we are just getting the hash and transferring here. And to get the hash, well, this is quite a standard code in order to resolve to a hash. Probably the most interesting thing is this last line that tries to emulate what would be a text in a normal DNS. Okay? Okay, at this point, well, I'm going to try to show you how it would work. Mainly, what we would do, what a normal user would do, is, okay, we have here internet. Okay. Here we connect to the VPN. Just is now connecting. Looks like it's connecting. Okay, looks like it's connected. And now, if I go here and just going to HTTP. Bailina.eth. Here the important part is that .eth. Okay, this is not, if you try to do that in a normal browser, this will not work. But now here it works. This is a page that I set up in here. Okay, so and well, this is. I'm going to show also another page that's I think it's interesting to show. One, if you remember, just a couple of months ago in all the Catalonia story, there was a web page that was censored. So you can see here, for example, if you go to catalan.revolution.eth, should go, and it will go directly to the page where it was censored, because this is in the IPFS, and this is it's almost impossible to get censored on that on that page. Okay, so mainly you see how we use the personal server just to connect to a pure decentralized web page in this case. But this configuration of a server, this configuration of the server does not only apply to the decentralized web. Any decentralized application could run in this server, and it's very useful when you are creating dApps to have this server, because a lot of times you need, for example, to have a kind of cache of the blockchain in some place where the user can access to this data quite fast. Another problem, for example, if you are trying to do a dApp, is that it takes a lot of time, for example, to synchronize the chain when the user starts. So in this case, you don't really need to wait, because the server already has synchronized the server, so you can go and access directly to your server, which is a trust server. Okay, and the idea of the project in here is just okay, we have like an operating system, we have some modules which would be quite standard, and then the user should be able to install different dApps or applications that are running in this server that can be, for example, in a repository, in a decentralized repository, where the people can choose which applications install in their server, the same way that they choose which applications they have in their iPhone or in their laptop. They can also choose which applications they have in the server. Some examples of these applications, for example, could be a decentralized search engine, which part of the server that's always connecting and always searching the net could be running here, for example. So here we have like a full place where a lot of applications can grow on this server. So, well, that's mainly my presentation on that. I hope you understand and you see the idea on that. We are working hard on this to be real. We are trying that these personal servers be something that to be very, very easy to install, so that as many people as possible be able to install and maintain these servers. And I hope that someday we just don't have more data centers, more centralized data centers anymore, and we have a full data center, which is one server for each of the individuals in the globe. And here is my presentation. Thank you. I don't know if I'm running out of time, but if you want a Q&A, that for me it's fine. Yeah.
Dankeschön, Team.
Hi. My question would be, if I run this, if everybody runs the personal server, does this also increase actually the security of Ethereum network?
Well, if in these servers there is a node in there, so as much nodes are in the network, as much better and much difficult to tamper, at least the relaying part. Other thing is the miners. This is not thing to be a miner. You could install here a miner if you want, but that's not the idea of this server. This server is more a connectivity server.
Hello, thank you for the talk.
Okay.
If multiple people run this decentralized data center, how would all the servers connect to each other? Because in the schema it was shown as peer-to-peer, but you haven't said how the servers would connect to each other.
No, it's this server. So the server has a set of tools, like, I don't know, a Bitcoin chain, an Ethereum chain, an IPFS chain, which is just a piece of code that's a decentralized code. This connects with the rest of the nodes via peer-to-peer. Peer-to-peer means that there is no central part where you connect, where you have to connect to. They just discover which servers are around, and they create a mesh network, a peer-to-peer, an overlay network, a peer-to-peer network, and there is a protocol in order to synchronize and all these servers. But the idea is to install peer-to-peer applications or decentralized applications, not a central application.
Okay, so every application is responsible for itself to find the other peers, and it's not there's like a mesh or I don't know, a cloud, in air quotes, created between all the participants.
Yeah. Here is just a regular application. This peer-to-peer application, they have a small trick. Is the bootstrap. The beginning when there is nothing, you need to say by hand which are the initial servers. But once the network is set up, then you just can connect everywhere, and the people is discovered. It's just for the bootstrap, this part. It's a kind of centralized, but for bootstrap. For the rest, once you are connected, then the network goes along.
If I want to run a personal server, is there a place where I find some resources like configuration here?
Okay.
At GitHub, or maybe is there something up to now, some resources to set up a personal server?
Well, the idea is, right now I have set up this server a little bit by hand, so just getting the different pieces and putting it together. But the idea of this project is that you install that the same way that you install an operating system. And you install an Ubuntu, or that you install, a Debian or any other distribution that you just set up. And it should be as much simple for the user as possible, because the idea is this to go mainstream and as many people as possible to create their own server and manage their own server. So it should be very, very, very simple, and I'm sure you should be able to run one of those. And your mother expects you to.
Question?
Not really a subject matter question, but since we have so much time left, can we look at your code slide again?
Oh, sure. This is the one. Do you have any doubt on that? Here I'm relaying in the HTTP proxy. HTTP proxy. That mainly what it does, it just forwards an HTTP connection. You just say here in the target, I target the URL, and then I just construct the URL with localhost 9001, this is IPFS. I didn't do nothing here. The IPFS already have a gateway that's published on port 9001. So I just put the content that I extracted from the blockchain in the URL and forward. That's just a glue. This is very much a glue code. And this is more Ethereum related, but well, at the end, this is very much how DNS works. But mainly what does here is just find the resolver for the node. The node is the name hash of a name. The mainly is a hash of the name that's trying to solve. And once we have the resolve, we just ask the text method to extract the DNS link key, and this will return the content. And this is the content that I catenate to the URL in the other side. But that's a very, it's a very simple code. It's just a glue code. That's
More questions? No questions. Okay. Then my last questions. Where can we find you here in the Congress? Do you have
well,
a business?
I'm just hanging around generally in one of the back tables. But I'm Jordi. You can find me also in Giveth Slack, slack.giveth.io, or in jbailina in GitHub or Twitter, LinkedIn, whatever. I'm a public person, so you can find me easily.
Thank you again for your amazing talk. Thank you, Jordi.
Thank you very much.